global community under pressure.
Yes. Okay, I think you can see this was yesterday. It just started, just 2 slides only yesterday. We are talking general. What is the issues with the what do you mean global warming, greenhouse gases? We have talked yesterday. Okay, so already I told you that the greenhouse gas is a major issue, which is actually destroying the Earth atmosphere, which in turn automatically, permanently, if they say that if you don't control the greenhouse gas emission, the temperature, average temperature may increases, summer will become hot, all those things. So because of that, people, animal, plants can extinct once for all, correct? That can happen. Like dinosaurs, all those things happen, same thing can happen. But this is a slow process. We know that dinosaur was, it is only argument or partial proof. Some meteorite, big one came and hit the earth and near Mexico in Atlantic Ocean. And it created so much dust, all those things. They covered entire Earth atmosphere so that the sunlight could not reach the Earth's surface. So if that means photosynthesis is not possible, the plants will die. Like no fruits, no vegetable, nothing. Animals cannot eat, and similar birds, everything extinct. They say one of the reasons for dinosaurs 65 million years before is from the asteroid hitting, right? Big asteroid measuring few kilometers size. Like that, Ice Age came and do like that. And they said now humans are creating their own destruction. Right? So that is why so many meetings, new technologies are coming. Okay. Now, yesterday I explained about greenhouse gas. I know that primarily our interest is reducing the carbon dioxide production or emission from the tailpipe, which was supposed to be inert gas. Right? It was called as inert gas. So that's why, as I told you many times, we drink soda, which is water plus some minerals, some sweetener plus carbon dioxide gas. It helps you feel good. It helps in digestion. Correct? We drink soda for many times, but that gas may be inert, but it is a greenhouse gas, which is slowly increasing average temperature. That should be avoided. Okay. Apart from the other gases also, I know that fridges, they don't, fridge, AC, all those things, CFC gases, correct, is already banned. Alternate gases are used for in the refrigerants, all those things. Of course, NOx production is also coming from the engines, combustion of hydrocarbon fuel. But please know the fuel doesn't contain nitric oxide. But if combustion temperature become above 1000 degree and the oxygen in the air, which is inside the combustion along with the nitrogen inert gas, but they can combine, correct? At low temperature inert gas, but higher temperature it can automatically combine with oxygen, you'll put NOx, NO2 something we call nitric oxides. And if they mix with water, you know that nitric acid in ice or plant flower food production and can induce skin cancer if you are walking in the, suppose raining, correct? You like, some people like drenching themselves in the rain. If you go in the rain, especially city environment, during first spell of the rain, correct? Now city has a lot of vehicle. The NOx from the tailpipe will be filled in the atmosphere in the city environment. Of course, it distributes everywhere more. And if you are walking in this one and suddenly rain comes, this first spell, the water will mix with the NOx gases, and nitric acid will be will be created. If it falls on the skin, it can create skin cancer, all those things. Same thing. So that is also not good. So that means if I stop burning the hydrocarbons like petrol, diesel, or any this one LPG or methane, all these things, if I stop burning, that means if I don't use it for getting energy from my engine, then you can avoid both carbon dioxide and also NOx production. So these two are the main contributors from the automobile for global warming as a greenhouse gases. Okay, now people, so now all this thing came, scientists came to know that carbon dioxide is a greenhouse gas only 30, 40 years before. Before that, I told you many times throughout the world for last 100 years, whether in the education universities like IIT, MIT, Stanford, Japan, all this one, the IC engine lab, main job is to improve the combustion efficiency, first thing. Next thing is reduced the toxic gases, NOx, CO, and HC from diesel engine or petrol engine by using catalytic converters or adjusting timing, all those things, so the perfect combustion happens. If it happens, these three toxic gases created, of course, the particulate matter can be reduced. That's why research going for last 100 years, but around at least 80 years, but some 30 to 40 years before, scientists and the automobile company researchers found that CO2 is a greenhouse gas, and the global warming started. That means you need to reduce the production of carbon dioxide. But we know that if I do combustion, petrol, diesel, definitely I am giving HC plus O2, automatically CO2 will come plus H2O. This is a perfect combustion. Even if perfect combustion, CO, HC, NOx is reduced, including PM in diesel, petrol. This is by using catalytic converter, SCR, all those things we are reducing. But this cannot be reduced because mass, you are supplying some amount of mass of the fuel with some mass of the oxygen in the air. So automatically equivalent amount of CO2, H2O will come because this is input mass, this will be output mass. Both should be equal except some fraction is converted to energy or power. Okay, so that means whatever you do, so that means if I want to stop production of CO2, I should start reducing the hydrocarbon or diesel, petrol injected inside the engine should be reduced. Correct? If I make it 0%, that means then my CO2 will be 0% automatically. That means that power and torque also will become 0. Correct? When it will become 0, carbon dioxide, that means no fuel. No fuel means engine is not combustion order, no heat, no pressure generator, no movement of crankshaft, no torque. So nothing happens. Energy is not produced. So in IC engine, it is impossible to stop using fuel. Without fuel, engine won't work. So one way, correct? Suddenly, as I told you yesterday also, suddenly without IC engine, you cannot do anything. Whether in industry, transportation, airplane, ships, wherever you are doing combustion, engines are there. Maybe they are LPG based engine, gas fuel, or jet engines. You are going to burn fuel, hydrocarbon. So only way is you can reduce the amount of CO2 produced is still if you want to use the IC engine. How? Making the engine more efficient. That means with less fuel burn, that means less CO2 will come. So, but still you get sufficient torque and power so that your vehicle is able to transport goods, passengers, whatever it is. So that it. So for last 30 years, main group of engineers, researchers, and automobile companies are working on increasing the efficiency of the IC engine or jet engine. It cannot be. We know that without that, there's no possibility of doing any work, correct? Whether in this one. So they're doing research, correct? We know that we are trying to improve the thermal efficiency. Thermal efficiency has a limitation. Already we based on only certain percent. If I burn a fuel if it generates for 100 joules of energy, not 100 joules will be converted into a mechanical energy. Chemically converted heat energy. I burned some X amount of fuel. I got 100 joules of energy, heat energy. The entire energy cannot be converted into mechanical torque and power or speed of the vehicle. Right? So that thermal efficiency, we know that 40%, around 40% thermal theoretical efficiency, auto cycle, diesel cycle, whatever cycle, you'll see finally there's a limit. Beyond that, you cannot convert. Definitely, it's not more than 40% or 45%. Theoretical itself. Practically, we are achieved now around 30 to 35%. Diesel engine may be higher, petrol engine may be little. In spite of talking about different technology developed last 100 years. Correct? CRDA, fuel, correct? Instead of carburetor, we start using fuel injector, port fuel injection. Then we started using GDI in petrol engine, now current generation. You from the diesel engine, unit injector to CRDA engine. CRDA engines are working very high pressure, 2000 bar, 1500 bar, so that all the fuel will be evaporated and it will become a energy. Correct? Particulate matter, NOx production is less. All those things we are trying. So that, in spite of that, correct? Still, we can go only up to theoretical. We are not reaching theoretical limit because now we are very closer. Even many times we say that I achieved. If you may doing IC engine research in IIT as a researcher, PhD scholar or in your company, suddenly one day I received 5% improvement. Correct? First question you need to ask you whether it is absolute improvement or relative. Correct? For example, currently your engine is giving, if you put 1 liter petrol, correct? It gives your engine gives 15 kilometers in your vehicle. Correct? Next time it gives 17 kilometers, new engine, or 18 kilometers, or 1 or 2. So based on the if you talk, it look big number. Correct? 15 kilometers become 18 or 17 is a big number, percentage wise. That is relative. But engine absolute performance will be generally 1%, 0.5% will give thermodynamic efficiency. Correct? Slowly, we are reaching. So, but whatever you do with heat engines, we call it heat engines, the maximum efficiency you can achieve is only 40% or 45%, not more than that. That means remaining 50% fuel is wasted. That is nothing can be done. It is already proven by thermodynamic law. So that means, do you have a machine which takes some input energy? It converts all the input energy close to 10%, at least 85%, 90% as a mechanical energy. So there only comes the electric motor. In petrol engine, diesel engine, an IC engine, you are giving chemical energy as a fuel. Correct? 1 kg fuel you burn, so many kilometers it has to give. So much mechanical torque and energy should be produced. As I told you, 50% remaining 50% automatically wasted, or 60% or 65%. But in case of electric motor, the input energy is electrical power. Right? I give so many volts, so much current flows, power equal to V into I. If you integrate the power consumed by the electric motor over the time, you will get energy. So if I give, say, 100 watts of electrical energy, you can get 90% of the mechanical energy, close to 90%. Electric motor, the energy conversion is close to 90% because there the heat is not, the machine is working for electromagnetic induction. Correct? Torque is produced by electromagnetism. So the motor, present generation motors are giving up to 95%, brushless DC motor, all those things. So if you can go for using electric motor to generate mechanical torque and power or energy to do any task, whether to drive your motorcycle, car, truck, bus, ship, or aeroplane, jet, instead of jet engine, use electric motor for propellers, driving propellers, whatever it may be. So then the efficiency is very high. And apart from that, CO2 is zero because you are using electrical energy. Input is a current and voltage. Okay. So now, before going further, what I wanted to say is this slide I showing that people, if you go and talk internationally, politicians, correct, or industry persons, engineers, scientists, frequent meeting, international conference, they talk about sustainable energy, sustainable technologies, and green technology. Correct? So, green technology, therefore, as a lighter sense, I'm showing this. Green, people talk about green building, green factory, green vehicle. This you will be hearing international conference, because I attend many conference once in a while, frequently in US, Germany, everywhere. People talk about this. There are conferences called green technologies, international conference, green technology, green buildings, civil engineers will be talking green buildings, correct? Green factories, like that. Lighter sense, take a building, paint it green color, correct? So it is not a green building. Similarly, you take a factory, inside the factory, all the machines, everything is you painted green color. It is not a green factory. Similarly, take a car, correct? For example, for a sports car, Ferrari or something like that, correct? You know that the fuel efficiency of a sports car is very, very bad, correct? Per liter, it may give 3 kilometer, 4 kilometer, 2, 1 kilometer, something, but they produce 1000 HP, 800 HP, 0 to 300 kilometers in state, 350 kilometer, but they are meant for them, correct? Higher acceleration, quicker response, all those things. The mileage will be very, very bad compared to IC engine itself. We are saying that very bad. Only regular, which is optimized by fuel economy, all those things, commercial vehicle, commercial cars. But sports cars, if you paint green color, it will not become green vehicle. So I said this is for lighter sense. What actually green means? Generating energy to heat the house. For example, India, at least we need fan, correct? Driving a fan or an air conditioner to cool the interior of house, or for cooking, correct? Like instead of using gas stoves, you use electric stoves, correct? Or fans, all those things. But the energy, electrical energy, instead of using burning instead of fossil fuels, if you use electrical energy to drive the load in the factory, fan, AC, fridge, refrigerator, cooking, everything in your house, and use electrical energy instead of burning LPG or kerosene or diesel, generator, all those things, then the building is called green building. The energy, it is using electric. But please note that that energy, electrical energy, should be produced from non-conventional energy sources or renewable energy sources, not by burning fossil fuels or coal in thermal power plants. So you can use solar cells or wind energy or geothermal energy, or you can use wave energy. These are all. So you know they go to beach throughout the year, correct? You will see waves. There's a wave motion. That motion will be converted to electrical energy using mechanisms, generator, all the mechanisms. So that is called a wave energy sources. Because IIT implemented one in Vizhinjam or something, Kerala, 35 years before. Still I remember when I joined IIT Madras, around 1980 and 80 itself, they were putting the wave energy, which can produce a machine, which can convert wave energy into electrical energy. This also tried worldwide. But similarly, geothermal energy, for example, wherever hot water springs, that means generally where volcanoes are there, correct? Like Iceland, Japan, many places where already these hot water springs are the geothermal, because under the 1 or 2 kilometers of the sun, you know, the magma is there, molten rocks are there. That comes up, we call as a volcano. We all know that. I'm not going to explain. There is nothing to explain. So that time, if water mixes, it produces heat and steam. And Iceland is one of the country, 90% of the electricity is produced from geothermal energy in the world, because there are a lot of volcanoes, open hot springs. From that steam are coming out, they are using for last 50 years. 90% energy they do. So if you use that, using steam coming from the geothermal heat, because of that energy using to drive your turbine and generate electricity, that will be used for heating, cooking, fan, all those things. So then it become a green building. That means you are going to use electricity, and the electricity produced will be renewable energy sources, like all the not burning. Then the building is called green building, not by painting green color. Similarly, factory also, because factory need energy. driving machines. That energy, if it is electrical energy, instead of using engines or the generated driven by engines, are getting energy from the thermal power source, power stations where coal and heavy oil is burned. We call then that factory is called a green factory, which uses electricity produced by renewable energy sources. Same thing, car. Car should be driven, it should be electric car, not IC engine based automatically. If we say green car, it should be electric car only. Pure green car, 10% green car means it should be electric vehicle, and the battery should be charged from solar energy, wind energy, not from regular grid where the fuel is burned at thermal power station, coal is burned. Okay, so that is what called green, not by painting this one. Color of the car can be red, whatever color it may be, but if the energy is electrical energy is used, and the energy electric energy produced from non-conventional, the renewables or non-conventional, then it is called green building. Generally, when we talk about car, automobile, because our interest is today, the whole lecture, the whole program is MTech in automobile technology, and the course is about hybrid vehicles only. We are not talking about factories, houses, nothing else. Not talking about green building or green factory. Our interest is talking about green cars. So, but green car cannot be achieved overnight. That's why we have different steps. So, but when you think about a car, we know that car means automatically we think about this. I took some picture from internet. Sports car, SUV, regular cars, all those things, race cars, all those things, they are all powered by IC engine, correct? Petrol or diesel engine only. Maybe power from the small car, maybe 30 to 40 bhp, to race car, sports car up to 800,000 bhp with the different shape, luxury, all those things. But they're all IC engine based. So these cars cannot be considered as a green car. If you drive this car, whatever with maximum fuel efficiency, even per liter it gives 100 kilometers, still you are burning 1 liter of petrol or diesel, and automatically you produce CO2. Right? So you are adding into atmosphere. So the atmosphere temperature increase. So we will know the global warming, greenhouse effect, and all those things is there. So you cannot avoid it. So these cars, the petrol cars, are just around 120 years old only. All the petrol diesel car, after invention of petrol engine by Otto and diesel and Rudolf Diesel, before that no IC engines. All the cars are powered by this only. Jet engine generally we do use for bus, truck, or cars. So we are not going to talk about. We are talking internal IC engines only. So these cars, even now, majority, at least 90% of the automobiles are IC engine based. As on today, at least 5 to 10%, we are trying to get hybrid, electric, all those things. But we need to convert remaining 90% also into pure electric car, so that the carbon dioxide production, IC engine is removed from vehicle. So then the CO2 production is stopped. Then the greenhouse gas is reduced, and we can protect our environment. So that means, but you cannot do it overnight. We need vehicles for transporting people, transporting goods. Without that, society cannot live. So, but as I told you, this came only 120 years before or 100 years before the engine is invented. Before that, automobiles, you know that for thousands of years, people were using transporting goods or people from one location to another. They were using animals like bulls, correct, or horses, donkeys, mules. And that's what used as a primary transportation some 5,000 years before. After that, they invented chariots driven by and also bullock carts, correct, driven by bulls or any other cows or any other animal, and horse-driven carts, right? Chariots, we call it chariots. They are used for transporting people in faster way, and also in the this one military purpose, correct? So so chariot was a part of the military, correct? Like horses, chariots, and elephants, and foot soldiers. They were there for last at least 3,000 to 4,000 years. up to at least 120 years before, at least 150 years before. Then invention of the petrol diesel engine, then you got aeroplanes, tanks, and all the mobile vehicles used in army as well as for the civilian purpose like cars, trucks, all those things. But before that itself, at least one, as I told you yesterday, in 1982 itself, they made a powered vehicle, which was an electric vehicle, which was developed by Robert Anderson. Correct? He is sitting under with his friends on his car. Please note that first automobiles are not IC engine based. It was an electric vehicle, started 1980s, 1950s, something like that. Subsequently, you can see that this photograph, I took it for internet, as I told yesterday. You are seeing lot of car. None of the car is IC engine based. It is 1900 beginning. That time diesel, petrol engine was just testing in the laboratory, diesel, all those things. Universities, they were not using. They are all by electric vehicle, electric motor powered by battery. Okay. So then hybrid car came. Now we are talking about hybrid car. Many times we talk via innovation, latest, all those things. Please understand that all these things were tried long before, 100 years before, 50, 70 years before itself. Correct? Porsche car, you know that one of the leading sports car manufacturer in Europe, they developed hybrid car. Correct? This is the car which Porsche, which is a hybrid car, which has electric motor with engine. Then Ford T model. So all these things were happening in 1900 beginnings, 1920, 1950, all those things. But the invention of petrol car engine, gasoline engine and diesel engine, and also the getting crude, correct? Extracting the crude from the earth, below the earth, maybe 1 kilometer, 2 kilometer below the earth, drilling and getting the crude oil. From that, extracting diesel, petrol is very tedious. That time technology was not available. People did not know the crude oil is there below the earth's surface. They invented, first crude oil was invented, if I'm correct, in Pennsylvania, USA, around 150, 200 years before. It was oozing out like a in a desert or in some forest, black color oil, this one, thick, it was coming out. People thought something is, then they found that it can, but if you put it, it get combustible. Crude oil is combustible. Then, of course, Iraq they found around 150 years British, because it was, Iraq was on British rule like India. So Iraq also they found the crude oil. From there, they developed technology cracking, correct? Petrochemical industry came slowly. The production of diesel and the drilling, and they are able to find out many places in Middle East, in the US, correct? Russia, many places in India also, Digbai, something like that, Assam, we are finding now. So production of petrol, crude oil production, from that getting petrol, diesel, all this thing came. So engine also invented. So the electric vehicle, which was started in the beginning, 1832, became a petrol engine in 4T model. Not just, I'm telling you, there are more than 20, 30 companies. Europe had Mercedes-Benz, right? Citroen. These companies are 100 years old, right? Fiat. All these companies started in Europe. Similarly, US, Ford started the very famous 4T model. It is a gasoline engine. It was very popular 1908 to 1912. Of course, still now, if you have, you can sell it for a very huge amount. Correct. So working. So the penetration, I call it the penetration of the IC engine inside the automobile. Original automobile, electric vehicle, that become a IC engine based. Of course, here I'm talking about 1900, 1971 or 70. NASA, we know that Apollo went to this Apollo missions. Armstrong, Neil Armstrong, along with another one more person, astronaut, they landed in the moon. They walked, correct? But first, this Apollo mission, they started with, I think, 2 to 17. Apollo 1, 2, 3, 4, like that came. In between, something was this one. 11 was the which first one landed moon, Armstrong. 17 is the last one, if I'm correct. Last Apollo mission was 17. Within the 69, I think, if I am correct, July something, Armstrong landed. Then Subsequently, another 2 years, another 7 more missions. They went up to 17. One mission failed, if I'm correct, Apollo 13. They could not, they went near moon, but they could not land. There's a big accident. They safely returned. Apollo 13, but other things, this one, each time 2 people. And in one mission, they took one land road because they want to travel by walk. Because you cannot moon, because limited amount of time only you can stay. In a short duration, if you want to survey, look for the material, all this thing on the run. So you need a vehicle. The first lunar rover, they call it, developed by NASA. They landed along with the astronauts. Astronauts, you can see that there are 2 seats. They sat and they traveled around 22 kilometers. The tracks are still available. You can see if you have correct. India is in the Chandrayaan and all those things. When they take photograph on this one, still the tracks of this vehicle is still there on the moon surface. It was 1970 or 71. Right? So that also electric vehicle only, because you cannot take the liquid fuel to this one because they evaporate, because vacuum. So they took an electric vehicle, they travel. Of course, automobile company also did not keep quiet. General Motor, GM, produced an electric car in 1973. Correct? You can see this car, a small car, and it was operated with lead acid battery. This is charging. This one you can see that, but they have very limited range. Correct? They are using lead acid battery. That was battery available. Lithium-ion battery was not available in 1970s. Lithium-ion came only some 20 years before. Even the concept, all those things, but commercially not available. It limited performance, and we will talk about that tomorrow. What is the limitation of electric vehicle? The range also, battery can, this vehicle can travel some 20-30 kilometers after start. The battery discharges. Again, you have to charge your lead acid battery for 10 hours. So you will travel for another 20-30 kilometers, stops. And the battery was very, weight to power density of the battery is very bad. It is very, very percentage, 10%, 12%. So because of all these things, GM said electric vehicle will not come. It is not feasible compared to IC engine base. Correct? So that's what they were talking. So even though they tried, other companies also tried. I'm giving one example. General Motors 1973 something they tried like that. Other companies tried, then they abandoned. Okay, but that's not our interest. But since all this thing happened 1970s, but one way is to improve. We want to reduce the CO2 production. Correct? That means you have to improve the efficiency of the engine. Apart from reducing, already we talked about it in the previous class. And when I talked about IC engine, that is for introduction of autonomous vehicle, I talked about it. But just to quickly go through, we try to develop new technologies to reduce the fuel consumption. Right? Reducing fuel consumption is amount of CO2 produced also reduced. So lesser the fuel, lesser CO2. Correct? But you want to get maximum torque, maximum power. And we know that in a petrol engine, the torque produced by engine is directly proportional to airfield ratio and spark timing. Correct? The best thermal efficiency is obtained in petrol engine when airfield ratio is 1.1. We are talking about the airfield ratio, correct? And that time, similarly, we not at exactly what stoichiometric, slightly leaner. Slightly leaner thermal efficiency in a petrol engine is maximum. That is around 15 something like that. Okay, so this graph shows that is one thing. The next thing is if you talk about SI engine or petrol engine, the torque T is proportional to AFR and spark timing. Correct? Spark timing, we say T. When you are giving start, correct? When you give the start of combustion or when you are giving spark. We know that from TDC, advance or retard. That's what you are talking. Depending on engine speed, you change the spark when it is given. 10 degree before TDC, 20 degree, 30 degree, or 35 degree, you will vary. So that means as a control engineer, already we talked, the SI engine can be controlled, torque can be, and the speed and power can be controlled by varying the airfield ratio and the spark timing. These two, if you vary, the indicated mean, right, power or we call it as a final shaft power, can be controlled. Correct. So this is one thing. So we did all the research now going around the IC engine labs or universities, industry, all this thing is trying to play with these two parameters, airfield ratio and the spark timing, and see that the engine produces maximum torque with minimal fuel, and so that automatically CO2 emission reduces, apart from reducing COHC and NOx. And again, we talk about maximum brake thermal brake torque, or that also happens on a particular time only, spark timing only in petrol engine. So again, will be electronically controlled, electronic spark timing control, electronic airfield ratio control. We have tried. So people have developed different type of fuel injection system, and advanced fuel injection system. Already we know that it is better than the carburetor based fuel, this fuel metering. Carburetor cannot achieve the level of fuel control and make the combustion proper, so that COHC, NOx, and also the thermal efficiency, all those things are increasing. That is possible only with fuel injection system. And fuel can be, if I want perfect combustion, the liquid fuel should evaporate and become a gas before combustion start or during the combustion. So all fuel will be burned. If all fuel is burned, then I get maximum torque. I can wastage of fuel is reduced, so CO2 emission is reduced. So different fuel injection techniques were used in diesel engine and also petrol engine. We know that spraying fuel improves the fuel vaporization. If fuel vaporizes, the homogeneous airfield ratio, so the fuel vapor easily mixes with air, so it gets oxygen molecule close to it. So all the fuel molecule will be converted into CO2 and H2O, so that the maximum heat, maximum pressure, all this thermal efficiency, everything happens. Vapor is very important. That is achieved by using fuel injection instead of carburetor. Okay, spraying makes easier to start, the cold start. All these things are much better in fuel injection compared to carburetor. Otherwise, you have to put the choke. Correct. We know that motorcycle. Anytime I had a motorcycle, I drove it for 20-25 years. In winter in IIT, summer in winter temperature morning, December this one, it will be 18-20 degree early morning. I had to go and kick my motorcycle because there was no starting motor. 10 times, 20 times, sometimes my leg will pain. I put choke, still it won't start. Correct. Sometimes because of very cold. In Chennai itself, think about going to Kashmir, North India, cold countries, European countries, US, Japan. It is very difficult. So the fuel injection system can automatically adjust the airfield ratio without choke. They call it electronic choke, inject more fuel, all those things. So fuel injection can help in cold start. Better mixing happen because fuel is already vaporized because of the small this one. So 3 type fuel injection did not come overnight. Currently, we are going GDA engine, latest one. First is throttle body injection. That means in multi-cylinder engine also, only one injector will be there in the plenum. Correct. Main this one throttle body, there will be a big injector. It will inject all the fuel. For example, 4-cylinder engine means it will inject the fuel necessary for all the 4 cylinders in one location. When air moves it, the air is set. The vapor will mix with it and go to individual cylinder. But main problem with the throttle body, a single point injection in multi-cylinder engine is mal-distribution of air-fuel ratio. Correct. For example, I have 4 cylinders, something like this. Right, piston is going. I inject the fuel here, central body. Air is coming in. When air, so I inject, fuel vapor is here. You can see that this area will be rich. So when air enters, when piston goes down, this will get less fuel vapor and get more air, this cylinder. But when next cylinder goes, the air goes in, but more fuel will come because fuel vapor is very close. So these 2 cylinders will get more fuel vapor compared to the last 2 cylinders. This is called central body or throttle body injection. This was came some 50 years before. Then they call maldistribution of the airfield ratio. Uneven torque production by different four. After four cylinders, these two will produce more torque and this will produce less because of all the problem came. Then they went for individual port fuel injection system. Individual port is single, there are injectors. Port cylinder means near the inlet port, you have that called PFI, port fuel. That's why you call PFI, port fuel. With a single cylinder port fuel injection system, with a multi-cylinder, MPFA, multi-point or multi-port fuel injection system, individual. So you control the fuel exactly for each cylinder. So that same airfield is maintained this MPFI removed the maldistribution of airfield ratio, which is a major drawback, throttle body single point injection. Of course, even when you do this, correct. So please take the notes when I show you slides, important points, please note it. Correct. Throttle body injection, what is the advantage? This one, because you have exams. So please note that you take the points I am discussing. So port fuel injection advantage compared to throttle body injection, this has advantage. Maldistribution, all this thing are removed, but still some amount of fuel will be sticking, what you call a valve wetting. I talked about it in previous class, but still I am saying, because you are injecting the fuel, petrol in the inlet port outside. Correct. So some amount of fuel will be sticking on the walls of the inlet port. It will not go inside the combustion chamber. So the exact airfield ratio is not maintained because valve wetting. So this cannot be avoided in port fuel or MPFA engine. So they invented gasoline direct injection because you are injecting the petrol like a diesel inside the combustion chamber. Of course, air is sucked in like a diesel engine, and then you are injecting fuel, but while automatically it mixes inside during the suction stroke. All this thing happen GDI, fuel is in, that means valve wetting is automatically removed in gasoline direct injection. Okay, these are the advantage of the fuel injection system compared to carburetor. Already we discussed in the previous course, but still why we are talking is the whole idea is on electric hybrid vehicle is reducing the fuel consumption, right? Reducing the fuel consumption as much as possible, but we cannot make it zero. If no fuel, engine will not work. So that means you have to go. But right now, in your one step, you cannot go to electric vehicle. There are limitations which we will see in the next class. And I want to do. So we know that port fuel injection, single cylinder, we got port fuel injection. There's only one cylinder like motorcycle, single cylinder. I'm injecting fuel. So some amount of fuel is sticking here. That is called valve wetting. It is a liquid fuel, it is sticking. Majority fuel go inside the combustion chamber along with the air. Some will be there. So that means this fuel is wasted. Correct? Because of the airfield is not maintained, then CO, HC emission, all this thing happens. Zero drawback. Same thing, multi-point means I inject each cylinder has one. This is one cylinder, second cylinder, third, fourth cylinder engine. Correct? So air is controlled by butterfly valve. Fuel is controlled, he injected directly inside the combustion chamber. Correct? So these are advantage compared to the single point injection in multi-cylinder engine, maldistribution removed. Gasoline, next is gasoline direct, GDI. Advantage, fuel direct injected inside the combustion chamber. High pressure is needed generally. 5 to 10 bar or 15 bar is the injection, but sometimes even a little higher. Different companies are using different pressure in the GDI fuel injection. Don't say that's how you said 5, 10. Some companies in 15, they can use 15, 18, 20. It varies the advantage. Fuel is direct injection. Then comes the top of the piston, which is called as bowl of the piston. That also shape is also very important, gasoline injection direction. Correct? The fuel should go, the air should go and make a tornado, like a cyclone. The air should circulate, then only injected fuel will evaporate, mix uniformly inside the GD engine. And it works on both, correct? Stratified as well as lean. Correct? Stratified, all those things that time, different this one. Whether somebody talked about this, I see somebody talk GD engine.
Yes, sir. Anand sir, when
yeah, that's right. So you would have talked. So all those things. So it works a homogeneous and stratified modes, and so this all to improve the engine efficiency, so that fuel can be use of the fuel can be reduced to get same mileage, same torque, same power. So CO2 production is reduced. So this is what I told you. Stratified means the fuel is, because the injector itself, the spray pattern changes. In GD engine, injector, if I want to run the engine at stratified mode, the injector will spray fuel such that it goes, you can see this is bowl, correct? Bowl shape. It is not a flat surface. You can see that the air comes in, correct? This is the air inlet. Sorry, this air inlet comes and hits, air will circulate inside, correct? There is a swirling action that is created by the shape of the inlet port under the plenum and also the bowl shape. So it makes here, this one. Now fuel is injected. Injected fuel will go near the spark plug. Because you are in stratified mode, you are injecting less fuel. That fuel should vaporize and go near the spark plug. When your spark is given, it should ignite. If the amount of the air fuel ratio is very lean near the spark plug, even if you give a spark, misfire will happen, combustion will not start. So in stratified mode, very important that the injected small quantity of fuel should be directed by the air and go near the spark plug. Then you give this. So they are stratified. Advantage is you can inject less fuel. In lean mode, you can operate. Correct? You can get more mileage in stratified mode. Correct? The fuel is injected, but once the combustion starts, this mixes automatically. Maybe 24:1, 22:1, or that one, you can run your petrol engine, get maximum mileage. But you will not get the power in stratified mode. Correct? But you want to get more mileage. Correct? No acceleration, moderate acceleration. But if you want more pickup, all those things, go homogeneous. You inject the fuel. So this is, see this the spray pattern. It is very small, stratified. Correct? And it injects like this. This is deflected by the piston top side, correct, which is a shape, and the air also is coming in and it mixes. Here you inject spray itself, a wider spray, and of course air is coming, it mixes the homogeneous, and more power, acceleration, although you run a homogeneous mixture, and stratified mode for light load or more mileage. So these are done to get the maximum engine efficiency. So CO2 is produced. Again, LPP, the whole idea is getting rid of CO2. How? By different technology. That's why I'm just talking. Diesel engine, already you know about it. Correct. The diesel engine also, NOx is produced, particulate matter is produced, some amount of fuel comes as partially burned, we call particulate. And there, to improve it, what they did, again, like MPFI or GDI, they call CRD, Common Rate Fuel Injection System. And you know about it. And again, you have the fuel pressurized to 1000 by 500 bar to 2000 bar, stored in a common rail. And there's a ECU. ECU will open injector. Each cylinder, 4 cylinders, 4 cylinders, diesel injector, high pressure vessel. They inject the fuel at high pressure. So the fuel droplet size will become very small, maybe 50 micrometer, 50 micrometer small, easily evaporate, and combustion noise reduces. Main thing advantage of diesel injection is combustion rate is controlled by injector. No doubt these points. Combustion rate is controlled by injection rate, like injection rate, spray angle, injection pressure, nozzle size, shape of the spray. All these things is combustion rate or combustion curve, what the rate and combustion happens, and the chamber shape and mixture motion, turbulence, like I told you, that is how you design the piston top shape of the crown. Okay, and then torque out is controlled by amount of fuel injector. Then main problem is automation. That is smaller the droplets is this one, it can easily evaporate and it will burn easily and produce less particulate matter. More torque you get. Correct. Combustion temperature should be controlled to reduce NOx emission. We know that if temperature goes beyond 1000 degrees centigrade, correct, the NOx is produced. So whether petrol engine, diesel engine, you have to control combustion temperature. But in the diesel engine is predominant. Compared to petrol engine, NOx emission is very high in case of diesel engine because diesel combustion produces more heat than petrol combustion. So that need to be controlled. Of course, if NOx comes, what do? You use SCR. Correct? So PW converter in case you use SCR by urea injection at the exhaust pipe quantity. so that the nitric oxide is converted back into nitrogen and this one, correct? So that you will get, that's what you do. There's a ECU and comes. But multiple injection, all those things. The last one engine is called homogeneous combustion ignition, which is called HCAA combustion. You know that this is a petrol engine, spark ignition. Air fuel is coming in, you give a spark, combustion happens, and piston is down. In case of the compression CA engine, diesel engine, air is sucked in, diesel is sprayed inside, combustion happens, it pushed down. So here you need a spark plug, you don't need a spark plug here. And in case of HCA engine, it works similar to petrol engine as well as diesel engine. They call cold combustion. I think definitely Professor would have explained on something I'm not going to explain. So here main advantage of HCA engine is NOx emission less, they call it cold combustion. Please note the cold combustion is not the 0 degree, minus degree, like this one. See here the temperature 800 degree average temperature, combustion. This may be around 400 degree or 450 lesser. So I told you can go to the 800 to 1200 degree also in diesel engine combustion. Here also 800 to 1000 degree can go. That's why NOx emission is produced. Correct? But in cold combustion means even though fuel is burning all those things, the temperature is much lesser than diesel engine or petrol engine. So the NOx emission is less, and the combustion happens in the entire this one is center because you are pumping pre-mixed fuel air mixture. I mix fuel and air outside and heat it, and the heated air fuel mixture is sent inside the combustion chamber. As in regular air, in HCA engine, air is sucked in, fuel is mixed, and together they are heated from normal temperature to higher temperature. Then it is sent inside the combustion chamber during inlet suction stroke. After that, it is compressed, and because of the higher temperature of the fuel air mixture and compression temperature increases, so already distributed, and you can see that multiple points the combustion happens. They call cold combustion. So the average temperature is much less. So NOx is very less in case of HCA engine, but it is very complex control system to HCA engine counter still under HCA. It is not counted as a commercial purpose. Okay, so that is the advantage. So just I want to stop in this. Advantage, stoichiometry, it can work as a stoichiometry like a petrol engine, and it can work in lean mode and static mode like GD engine, and it can work like a regular SA engine, and it can stoichiometry, lean, static, all these things are petrol engine, right? But the fuel is burned without spark plug. Please note that AC engine also there is no spark plug. No spark plug like a diesel engine, but you are mixing fuel all those things because that is an advantage. So you use the stoichiometric air fuel ratio, low part load efficiency, major problem is low this one. Low stoichiometric air fuel ratio, charge condition in HCA engine, low part load efficiency. The drawback, low emission catalytic converter this one. Lean mode, if you run the same engine, lean mode like SA engine, reduce pumping work, improved part load efficiency. But work is reduced, so efficiency in part load condition, but HCA and environment increases. If you run the HCA in the stratified mode, like a JD engine, please see that it's not a different same engine, you can mode different mode. That is the advantage of the HCA engine. So it becomes very complex to control by the HCA engine. JD itself is very difficult because you are changing the injector. You need a special injector, not an injector can be used. It uses spray pedal, so special injector is needed. Static mode or homogeneous mode. So apart from that, you have to do this. Static mode advantage. Large problem with this negative is NOx is produced, particulate matter comes, and pumping work is reduced, so improve. And HCA, these are the petrol engine. If they run in different mode, correct? We are talking so in HCA engine, everything is made except the control is very difficult. You achieve the advantage both stratified, mean burn, osteometric, all these things are combined and you can achieve, but control system is very difficult. So I stop here. So tomorrow, there's no sorry. I will conference in summer day. Tomorrow I have a lecture in a conference. Online lecture 6 to 7:30. I will take the class tomorrow. We will have conference class maybe next week or later. See you on Monday evening 6 o'clock. Please give your attendance. Please give your attendance. Chat before you.
Yes, sir.
Yes, sir.
Okay, have a nice weekend. Thank you. See you. I know another 3 days are there, but still, we are going to be done with the session. Thank you.
Thank you, sir.
Yeah, thank you.
Yeah, thank you, sir.
Thank you.